We've just now completed the history portion of this section, and we're going to move on to actually how computers work and learning the binary numbering system. I've alluded to the binary numbers several times in the past few videos, specifically regarding transistors and how they hold ones and zeros, and that's the basis for all digital information. And in this next couple of videos, you're going to learn how to actually read and write binary numbers. So let's start with, first of all, getting my tablet working here. I've got a tablet set up so I can hopefully write on the screen and narrate what I'm saying. So binary numbers is a numbering system where we only have two symbols. Bi meaning two, like a bicycle. So we have ones and zeros. Let me put a comma there so you can see that's two different symbols. Now let me compare that to decimal numbers. Decimal numbers, of course, the first part of this is DEC, Dec, which means 10. And what are our 10 symbols? A lot of times we forget about the little zero, but that's important. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. There is no symbol 10 because 10 is just a combination of a 1 and a 0. So these are the 10 individual symbols that they have designated. And this is what we use. We use decimal numbers all the time. We use the number 386, for example, where that would not exist in binary because it only can be 1 and 0. In binary, you're going to have numbers like 1, 0, 1, 1, 0, 1, 0, 1, and it's just lots of ones and zeros. So how do we convert back and forth? How do we actually make these numbers make sense to us? So in order to do that, I'm going to actually start with learning decimal. You may already know how to read a number, but I'm going to write it in a little different way. And let's actually make a little bit longer number. Let's make the number 7,386. Okay? So I'm going to rewrite that number down here. And I'm going to rewrite it in a little different form, but hopefully one that makes sense. Of course, this is the ones digit, this is the tens, this is the hundreds, this is the thousands digit. So what if we wrote 7 times 1,000, put a little parentheses in there, plus 3 times, well, this is the 100s place, plus 8 times 10, because that's the tens place, plus 6 times 1, because that's the ones place. And hopefully that makes sense. You have 7,000 plus 3 hundreds plus 8 tens plus 6 ones gives us the number 7,386. Hopefully that makes sense, but I'm going to rewrite it one more time in a little bit more, a different form. Instead of putting 1,000, I'm going to write 10 to the third power. Is not 10 to the third 1,000? See, 10 to the 1, 10 squared is 100, 10 to the third is 1,000. So that's actually the same thing mathematically. Okay? So let's keep going. 3. Now this number is actually 10 squared. Plus 8 times 10 to the first. Do you see a pattern forming? Now this one you have to kind of remember some algebra rules. 10 to the 0 is a 1. So that's the same thing mathematically. Okay. Now the reason that's important is there's a pattern here. And you're going to learn that the binary numbers have exactly the same pattern. That's why we're going to learn this first. This is always 10 to the 0, and then 10 to the 1, 10 squared, and 10 to the third, times the actual value of each digit. An example, 7 and 3, 8 and 6. Now why 10? Why is that 10 and not 100 or 5 or 2 or 9 or 0? Well, how many numbers do we have in our numbering system? We have 10. Can't draw a straight line here. So if we have 10 numbers, that's why they use the number 10 here. So it's always 10 to the 0, 10 to the first, 10 to the second, 10 to the third. So let me see if I can make my sheet a little bit longer here. And let's see, let's make it about 8 inches. Okay, so we're just going to continue down. Now, I'm going to change my pen color here just to say we're not doing decimal anymore. We're going to do binary. Okay, now the reason we start with that, this is exactly the same system, and you'll see how. Okay, so I'm going to give you a number. Let's do 10101. Okay, so what would that number be? Well, let's write the same number system. I'm going to spread this out. 1 0 1 0 1. Whoops, ran out of room here. 1. Okay, so there's our number. Now here we said times 10 to the 0. Well, we did 10 because there was 10 symbols. How many symbols do we have in binary? Only 2. So we're going to write times 2, but you're still going to do 0. Here we're going to write times 2 to the 1 times 2 squared. You see a pattern forming? Times 2 to the third times 2 to the fourth. Okay? Now let's go ahead and work each one. And remember, these are all added together. Just like we added up here, see the little addition symbol? We're going to add these together. So add, add. I should have written these as I wrote it, but I did not. Okay, 2 to the 0 is 1. Remember that. Anything to the 0 power is 1. So 1 times 1 is 1. Plus 2 to the 1 is 2. But 0 times 2 is 0. 2 squared is 4. 1 times 4 is 4. Plus 2 to the third is 8. But 0 times 8 is 0. And 2 to the fourth is 16. And 1 times 16 is 16. So now let's add this up. 16 plus 0 plus 4 is 20 equals plus 1 is 21. And we want to get in a habit of writing base 2 for a binary number and write 10 for a decimal number so that we know, or we're very clear that this is decimal and that's binary. So this, and I'll rewrite it up here, is equal to 21 base 10. Our number system is equal to 10101 base 2. Okay, let's do one more of those, and then I have a little bit of a shortcut to show you. Okay, so let's do 1 1 1 1 0 1 1 1. Let's say. Okay, so we're going to write 1 times 2 to the 0 plus 1 times 2 to the first plus 1 times 2 to the squared plus 0 times 2 to the third plus 1 times 2 to the fourth plus 1 times 2 to the fifth plus 1 times 2 to the sixth. I'm not sure why my pen keeps going downwards. So notice the pattern. Just 2 0, 2 1, 2 2, 2 3 to the 4 to the 5 to the 6. Okay? Now, and here's some numbers you may want to memorize. 1, 2, 4. They're just doubling, but 8. Can't find my pen here. 16, 32, 64. Okay? Now, this one was 1 times that. This one was 1 times that. This one was 1 times that. But this one was 0 times that. See that 0 right there? And this one was 1 times. I keep losing my pen. Where did my pen go? There's a tab. I haven't used this tab. There we go. 1 times 2 and 1 times 64. All right. So this one's going to, let's do some math here. 1 times 1 is 1. 1 times 2 is 2. 1 times 2 is 4. 0 times 2 is 0. 0 times 8 is 0. 1 times 16. 1 times 32. 1 times 64. All right, so let's do, and remember these are all added, 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 and added. Okay, let's see if we can do some math, hopefully in our head. 64. Actually, let's just write it out here so we can see what we're doing. 64 and 32, that would be equal to 6 and 9. That's 96. We need to add 16 to that because of that number right here, right Well, I can't point at it, but you get the idea. 16 is next, so we have a 2 and 11. That should be added 16 to that. We need to add a 4. That's 116. Let me rewrite that up here. 116. And then we have a 2 to add to that. So we have 118. And then we have a 1 to add that. So that is 119. So a little bigger number. This is equal to base 2 is equal to 119 base 10. Okay? Now for a shortcut time. So let's do that same number. Need more page here. Let's make it 15. Should be plenty for this video. Okay. Here's a shortcut. Do you like shortcuts? Okay, we start with the number 1, 1, 1, 0, 1, 1, 1. Okay, so instead of doing all that math you see up there, we're going to write the number 1 above that number, 2 above that number, 4, 8, 16, 32, and 64. Okay? Now, anytime you see a 0 down here, we're just going to cross it out. So, we're going to, I'm losing my cursor a lot today. Okay, so because 0 is not going to factor in, we need that placeholder to skip over the 8's place, but we know that there's not going to be any numbers added because of 0 times. 0 times anything is 0. Okay, and you just add up what's left over. So 64, 32, 16, 4, 2, and 1 is equal to 119 base 10. Okay, so let's do another one of those. I'll do a smaller one this time. So let's say we're doing 1, 0, 1, 1. 1, 2, 4, 8. Don't care about the 4. 8 plus 2 is 1 equals 11 base 10. So this base 2 is equal to 11 base 10. Let's do how about 1, 0, 1, 0, 1. We haven't done that one yet. Okay, so 1, 2, 4, 8, 16. Don't care. Cross them out. 16 plus 4 is 20 plus 1 is 21. Okay, so that's base 10. So that's basically how I recommend most people converting from the binary to the decimal numbers. One more thing I want to show you, kind of the pattern of how some of these numbers work, helps you understand. I want you to think, we're going to count in binary, and I want you to think of an odometer on a car. You know, the odometer keeps track of the mileage. Now, in the olden days, you would see an actual mechanical odometer, and it would roll over the numbers. The numbers would roll in like a wheel. So that means that when you had the number 999, you would watch it, and slowly the 9 would roll back to a 0. This would roll to a 0. That would roll to a 0. And then the next digit would be increased by 1. So it was like 0 before, so it was increased by 1. Binary works the same way. So what we're going to do here is I'm going to write 0. Now the difference is we're going to have to roll over, so to speak, when we get to after a 1, not after a 9, because that's the highest digit. So we're going to go to 0, we're going to add 1. Now we need to, well, we're full. We cannot have any more digits, so we're going to roll over and add 1. Now we can add 1. Now we're full again. So we're going to roll over and add 1. We're full again, so roll over, add 1. Now let's add 1 to that. That's pretty easy. Now we need to add 1, but we're full, so we'll roll over to that. Let's add 1 to that. That's easy. And now they're all full, so we're going to go 0, 0, 0, 1. Okay, now just to show you what we've done, let's count. Let's go back. This is the number 0. That's 1. Now we remember, if we wrote 1, 2, cross that out, this would mean that's 2. If this was a 1 and that's a 2, then that means nothing gets crossed out. That's a 3. If we wrote 1, 2, 4, those get crossed out, so that's a 4. 1, 2, 4, that gets crossed out. 1 and a 4 is left, that's 5. And then you have 2 and a 4 is 6. nothing gets crossed out, all get added, and then 1, 2, 4, 8 all get crossed out except for the 8. So as you can see, we have been counting, 1, 2, 3, 4, 5, 6, 7, 8 in binary, and you can see how they kind of roll over just like an odometer. And there's also a pattern here. I kind of wrote over some of my numbers, but 0, 1, 0, 1, 0, 1, 0, 1, and the next digit is 1, 1, 0, 0, 1, 1, 0, 0, and the next one there's 1, 1, 1, 1, 0, 0, 0, 0, and so on. So there's a definite pattern you can actually see in binary numbers. So that's going to be it for this video. Hopefully after this video you can take any number, let's say 1, 0, 0, 1, 1, 1, 0, and you can tell me what binary number that was. Even if you just use a shortcut, 1, 2, 4, 8, 16. We're just doubling these numbers, 32, 64, 64, and 16. I'm sorry, these get crossed out. So we cross out this one, we're left with 64 and 8, 72, 76, 78, cross out the 1, so that should be a total of 78. So that is converting from binary back to decimal numbers.